Here we have a SAT math problem. Okay, let's go to the question. A circle is inscribed in an equilateral triangle as shown above. Point L is the center of the circle. Points A, B, and C all lie on the circle and the sides of the triangle. The perimeter of the triangle is a 90 times square root of 3. The length of arc AC is equal to K pi. What is the value of K? Okay, here we have the length of arc AC. The arc AC is over here. We have length for this arc, that is K times pi, and in which we have to find the value of this constant K. Okay, here let me consider that is the length of arc AC equals to K pi, and we have formula to get the length of an arc, that is theta divided by 360 degree times the circumference of the circle, that is 2 times 5 times r equals to K pi. On the left side, there are two unknowns. One is theta and other one is r. This theta represents the central angle of the arc. So here, this is the angle theta, central angle of the arc AC over here. And this r is the radius of the circle. Once I get the central angle of the arc theta and the radius of the circle, I can plug in over here and here. Then I can solve for k in this equation. Okay, now to get the value of k, we need the central angle of the arc theta and the radius of the circle r. Okay, how do you have to get it? Now, let's consider this equilateral triangle. Since it's an equilateral triangle, at each vertex we'll have the interior angle 60 degrees. Here we'll have 60 degrees, and here we'll have 60 degrees, and here we have 60 degrees. Okay, now let me draw two radius to the circle from point, from the center L to the point C, and from the center L to the point A. Okay, here I've drawn two radius to the circle, and we know that this PA is tangent to the circle from the external point P, and this PC is also tangent to the circle from the same external point P. When we draw a tangent to a circle, at the point of tangency, the angle between the radius and the tangent is always right angle. So here we have right angle, and here we have right angle, and we know that this is the central angle of the arc AC, and we assume the measure of this angle as theta. Now let's consider the quadrilateral PALC over here. In a quadrilateral, the sum of the four interior angles are equal to 360 degrees. Okay, now let me take the first interior angle theta. The second interior angle is a right angle, which is 90 degrees. The third one is 60, and again we have right angle. Okay, here I have taken four interior angles of the quadrilateral. So the sum equals to 360 degrees. Okay, now let's solve for theta in this one. When I add 90, 60, 90, I am getting 240 equals to 360. Now when I subtract 240 from both sides, I am getting theta equals to 120. That is the central angle of the arc is 120 degrees. Let me replace this theta by 120 degrees. Okay, now we got the central angle of the arc, that is we got the value of this theta. Still we have to get the value of this arc, that is the radius of the circle. Okay, how do you have to get the radius of the circle? Now, let me connect the center of the circle L and the external point P over here. Since we have PA and PC are two tangents to the circle from the same external point P, the line segment which connects the center of the circle and this external point P will bisect this angle. Already we know that this is the measure of this angle is 60 degree. Then it will be bisected, that is it will be divided into two equal parts. Then the measure of the angle over here is 30 degree. And this side also will have 30 degrees. And the same line segment will bisect the central angle over here. That is, it will be divided into two equal parts. Then we'll have a 60 degree angle measure over here. Now let's consider the right triangle PAL over here. Actually, it is a 30, 60, 90 special right triangle. In 30, 60, 90 special right triangle, the side which is opposite to the smallest interior angle 30 degree is considered to be the shortest leg. And here AL is the side opposite to the smallest interior angle measure 30 degrees. So AL is the shortest leg, and usually we assume X as the length of the shortest leg in 30, 60, 90 special right triangle. Then the next longer leg is the side which is opposite to 60 degree interior angle measure. Here PA is the side which is opposite to the interior angle measure 60 degrees. So this is the next longer leg. Now to get the length of this leg, we have to multiply the length of the shortest leg x by square root of 3. Then x times square root of 3 is the length of this leg of the triangle, and the length of the hypotenuse, that is PL, which is opposite to the right angle, has to be 2 times the length of the shortest leg, that is 2x. Now my aim is to get the value of x which gives the radius of the circle over here. For that, we can consider the information we have over here. That is, the perimeter of the triangle is 90 times square root of 3. The given triangle is an equilateral triangle, so all the three sides are equal in length. Now, to get the length of each side of the triangle, we have to divide the given perimeter by 3. When I divide this one by 3, I am getting 30 times square root of 3. That is, the length of each side of this equilateral triangle is 30 square root of 3. And it's an equilateral triangle, and we have this point A on the circle and also the side of the triangle PQ. Then this point A will divide the length of the side PQ into two equal parts. That is, it will divide this 30 times square root of 3 into two equal parts. Then the length of this line segment PA is half of this one, that is 15 square root of 3. Okay, here already we got the length of this line segment PA, that is x times square root of 3. Now we got it 15 times square root of 3. So both of them represent the same stuff. That is the length of the line segment PA. At the place of x, we have 15. So the value of x is 15. So therefore the radius of the circle is 15 units. Okay, now we have the central angle of the arc AC, that is 120 degrees, and the radius of the circle, that is 15. Now we can plug in the central angle 120 degree for theta over here, and the radius 15 for r over here, and solve for k in that equation. Okay, now let me plug in, that is 120 degrees divided by 360 degrees times 2 pi times the value of r, that is the radius of the circle is 15, equals to k pi. Okay, now let's do some simplification over here. 120 goes into 120 one times, and 120 goes into 360 three times. 3 goes into 3 one times, and 3 goes into 15 5 times. Here 1 times 2 pi is 2 pi. 2 pi times 5 is 10 pi. On the right side we have k pi. Now let me divide both sides of this equation by pi. Then the pi will cancel out. Here the same. We get 10 on the left side, k on the right side. Here I got the value of k. The value of k is 10.